Good morning, good afternoon, good evening to everybody, depending on where you are. It is Wednesday, 16th of July. That means that we are just a few short weeks away from VMware Explore in Las Vegas. I know a lot of folks are registered already. Looking at some of the registration numbers, they are amazing. Going to be a ton of people there this year. Registration is open, and as of yesterday, the schedule builder is open. So now not only can you go look at the catalog and see some of the things that we have to offer, everything from our GM sessions to technical deep dives to meet the experts, all of our breakout sessions. You can actually now start scheduling. Customers are allowed to start, customers, partners, etc., are allowed to start scheduling. Employees, you got to wait. Broadcom employees are on will call. So any of you out there who are thinking, "Oh, I'm going to go do that," we want to make sure that the rest of our guests get priority for that registration or for the session registration. So go register, get your tickets. A lot of benefits come with those tickets this year. And registration is ready. You can go ahead and scan that QR code or go to vmware.com/explore and get yourself in and take a look at some of the things we have to offer. And speaking of some of the things that we're going to have to offer, it's going to be a very VCF9 intensive week. Kyle Gleed, how are you? Good to see you.
Hello, doing well, thanks.
Excellent. And I know you've got a couple of sessions as well as you're doing MTE and a bunch of other stuff that week as well. You're going to be a busy guy.
Yes, a busy week for me.
Outstanding. All right. Well, with that, looking, we got a ton of people, 300 coming up on 350 people in the audience. I think we can kind of go ahead and get started. I know you got the rest of the gang locked and loaded and ready to start here. So I'm
All
going
right.
to go ahead and pass the share over to you.
All right, thanks, Anders, and thanks everyone for taking the time out of your day to join us today. So we're going to have several presenters. We're all part of the VCF division. We're all part of the technical marketing team. And as far as the agenda, we've got a lot to get through in the next hour, so we're going to go through this kind of quick. So if you have questions, do put those in the Q&A. We do have folks who are monitoring the Q&A, and we'll try and get those questions answered the best we can. I'm going to start us off with a quick introduction to the new VCF installer and show how we've made it very easy to get started with deploying and updating to your environments to VCF9. I'm then going to hand off to Fidelum, who's going to give us an overview of some of the new features and capabilities available in vSphere 9. We'll then hear from Pete, who will talk to us about some of the new storage capabilities, primarily around vSAN and stretch clusters. Then we'll hear from Dimitri, who will go into VCF networking and some of the new things around virtual private clouds. And then we'll hear from Puneet, who will talk about VCF operations, HCX, and workload migrations and workload mobility. And then he'll come back to me, and I'll wrap this up with a quick overview on the new VCF operations fleet management capability. So that's our agenda. So again, put the questions in the Q&A. We're going to be passing the baton across numerous presenters. So hopefully we'll be able to get to your questions and get you the information that you're looking for. So with that, let's go ahead and jump in. And I'm going to start by introducing the new VCF installer. So the new VCF installer, this is a new installer. If you're familiar with the old versions of Cloud Foundation, you might be familiar with the old Cloud Builder. This is a replacement for the Cloud Builder. One thing to note is, despite the name VMware Cloud Foundation or VCF installer, this same installer is used to deploy both VCF and VVF. So if you're a vSphere customer, you want to have automated deployment, you have that with the VCF installer. It does a full stack deployment. It can deploy everything from deploying your vCenter to setting up your clusters, to configuring your vSAN data stores, to deploying NSX, configuring NSX, as well as deploying operations and fleet management. So it's a full stack. It is about 2 gig in size. You'll download it from support.broadcom.com. And one thing to note here, since we're talking about the VCF installer, is that when you go out and you go to download it, you'll notice here I got a little snippet of the actual support.broadcom site. You'll notice when I go to the VMware Cloud Foundation installer, it actually links me to an appliance called the SDDC Manager. No, that's not a bug in our download site. What it is the VCF installer is a feature that is built into the same OVA appliance as the SDDC Manager. So when you download the SDDC Manager, you get both the binaries for the VCF installer as well as the binaries for the SDDC Manager. It's all bundled in the same appliance. When you deploy it, it by default will run as the installer, and then depending on your situation, it will reconfigure itself to act as the SDDC Manager as needed. So that is the VCF installer. In terms of how it works, this is the UI. It's pretty straightforward. You basically log in, and the first thing you'll need to do is you'll need to download the binary. So I mentioned the installer was about 2 gig in size, and if we can compare that to the old Cloud Builder that was over 20 gig in size, it is significantly smaller. And part of the reason for that is because we no longer include all the binaries with the installer. So when you download the installer, one of the first things you'll need to do is set up a depot and download the binaries. When you set up that depot, you'll have a choice of doing an online or offline depot. So if you're a disconnected site or you don't want to connect directly to the internet, that's fine. You can set up an offline depot. If you are connected and you are connected to the public repository, it's very easy to set up that online depot. You simply go out, get your download token, go in, provide that token, and it will automatically make those binaries available for you. And you'll see here you can download both the VCF binaries as well as the VVF binaries. They'll all be available to you. Once you've downloaded the binaries, you can then go in and you can deploy. And you have two options for deployment. We have the deployment wizard, which is basically a UI that will walk you through the steps. It will ask you all the pertinent questions about, networks, subnets, names, and things like that that you need. And it will gather those and then do the deployment. If you are doing multiple deployments, say you're part of a professional services or you're somebody who's doing a lot of deployments, you can capture that into a JSON spec and import that JSON spec to avoid having to run through those same wizard-driven workflows every single time. So we have both the wizard-driven approach as well as that reusable JSON. When we deploy, you can deploy either a new VCF fleet with VCF 9. VCF operations is now a required component. And VCF operations together with the fleet management and VCF automation are what we call fleet level components. These are components that run, and you can have multiple VCF instances registered with these fleet level components. So when you deploy from the VCF installer, you can indicate whether you're going to deploy a new instance of VCF operations, a new instance of VCF automation, or whether you're going to be creating a new VCF instance and joining an already deployed instance of operations and automation. So you have that flexibility as well. And with this, you'll also, it's good to point out that with the VCF installer, we no longer have a separate command line tool for importing existing infrastructure. With the installer, you can basically say, hey, I'm going to deploy Cloud Foundation, and I can point it to an existing vCenter server, an existing VCF operations instance, and say, hey, I want you to convert this existing infrastructure and make that my VCF management domain. So that is built into the UI. There's no longer a separate tool. And as the slide calls out here, we can bring in existing vCenter, existing VCF ops, existing VCF automation. The catch here is with VCF 9, you'll need to upgrade all those components that are going to be imported to version 9 before you can bring those in. And then the last thing I'll kind of point out here about the VCF installer is when you go through and do the deployment, you do have a choice between doing a simple or a high availability deployment. And essentially what that means is we're making it easier to deploy VCF with a smaller footprint. So instead of having 3 NSX managers, instead of having a 3-node cluster for operations and a 3-node cluster for automation, we allow you to get started by deploying a single appliance for each of these with a smaller footprint. That's the single node mode. And then we also retain that ability to deploy these things in high availability clusters for those production deployments as well. And along with the installer, another feature we have, and again, it's good to point out that VCF operations is now a required component with both VVF and VCF. It has a very important role in that this is how you will license your environments going forward. But in addition, you'll find that, and this is particularly relevant for any existing VCF customers who may be familiar with the SDDC manager, as you'll see with VCF 9, we're moving a lot of that SDDC manager functionality into VCF operations. And one of the more significant of these features is the ability to import existing vSphere environments into Cloud Foundation as a workload domain. And you'll see here from the VCF operations UI, we can select our VCF instance, and we have the add workload domain where we can either create a new workload domain or we can import a vCenter. So the ability to create workload domains is now part of VCF operations. Very nice UI, very easy to use, very easy to bring that, both deploy new infrastructure as well as bring those existing environments in. And one of the things that's nice about the import feature is when we're deploying a new instance of VCF, I mentioned you had to upgrade everything to vSphere 9 and above. With the import feature, we can bring in those legacy environments running vSphere 8.0 update 1 and higher, as well as NSX 4. I think it's 4.1 and higher. That's actually a typo on my slide. And another thing to note here is when you do create a new workload domain or you import a vCenter to create a new workload domain, it's important to understand that when you bring those environments in, NSX will be deployed. NSX is a required component. It will be deployed. However, with that said, you do not need to change any of your networking. You don't need to adopt any of the virtual networking. You may continue to use your VLAN-backed port groups with your VDSs. And just be aware that the NSX Manager cluster will be deployed and it will be available for you so you can start to take advantage of software-defined networking and particularly the virtual private cloud or VPC capabilities that Dimitri is going to talk to us about coming up in a little bit. And so with that, I'm going to now hand off to Phelim, who's going to go into vSphere and what's new with vSphere 9.
Perfect. Thank you, Kyle. Sorry, I was just answering some questions in the Q&A. Let me just start my screen share. Okay, so I'm going to talk about some of the core vSphere technologies that support VCF 9. First thing we'll talk about here is live patch. Now, you might remember live patch. It's something we first introduced actually in vSphere 8 update 3, but we've actually made it a lot better in VCF 9. And the patch that we released yesterday, the first patch for ESX 9, that supports live patch. So for what live patch allows us to do is patch ESX clusters without having to do that lengthy and timely evacuation of all the virtual machines. So patching a cluster is the act of patching is relatively short. You patch the host, you reboot, it's done. Where the time takes is evacuating the hosts of all your virtual machines. You could have 100 VMs on one host. It takes a long time to evacuate that host and then repopulate it. So by being able to do the patch with leaving the VMs in place, dramatically reduces that total remediation time. So we're able to patch a lot more of the ESX subcomponents in 9.0. We can patch aspects of the VM kernel, user space, which is things like the host D daemon, NSX components, and the VMX components that we introduced in 8 update 3. Now, if virtual machines need to be reloaded or refreshed when the ESX hosts are patched, they go through what's called a fast suspend resume. And this isn't a new technology for live patch. It's something that VMs have been doing for several releases. If we're hot adding any hardware, adding a NIC, a disk, hot adding CPU, things like that. It's a very, very fast and non-disruptive reload of the VMX process, essentially. Now, not all patches will be live patch capable. It will depend on a patch by patch basis, but it is great that we've released our first patch for ESX 9 and it is live patch capable. So I urge you to take advantage of this and use it in your environments. Now, the next thing in the lifecycle space is support for mixed vendor clusters. This was something that has been asked for quite a while from customers. When we first introduced the vSphere Lifecycle Manager method of doing things with a single image baseline or the single image way of doing things compared to baselines from Update Manager, we lost the ability to support mixed vendor clusters because the VLCM method assumed a certain homogeneity for all your hosts in the cluster. It assumed that all the hardware was the same. Now in VCF 9 and vSphere 9, we can still use that single cluster image model, but we can create some additional images, almost like child images. And within those additional images, we can customize aspects of the vendor add-on, the firmware, the hardware support manager, and some components. So you can have a mix of, let's say, HPE hardware and Dell hardware coexisting in the same cluster and still using that single cluster image methodology. We support up to 4 additional images. So that gives you a theoretical maximum of 5 different hardware types that you could have within a single cluster. Now, that's not necessarily something that I would recommend. We still do recommend that where possible, you try and keep your hardware more uniform across the board. It makes things a lot easier. It makes your life cycle easier. It makes just managing your cluster a lot easier. Now, the other thing that we also introduced in vSphere 8, but we've taken it a step further, is memory tiering with NVMe. We introduced this as a technical preview in vSphere 8, and it's now fully production ready in VCF 9. What memory tiering allows us to do is take NVMe devices and essentially present them to ESX as memory, as RAM. You'll see on the DCUI, that yellow and black screen when you boot ESX, you'll see a larger total memory because it's going to account for the NVMe devices that you've claimed for memory tiering. And what ESX does under the hood is it moves cold pages of virtual machines to the NVMe tier of memory. Now, while NVMe is quite fast, it's still magnitude slower than DDR. So we leave the hot pages in the faster DDR memory, and we move cold pages to the NVMe tier. This allows for a greater total VM consolidation, a much larger VM density per host. Now, this is enabled at a per cluster level when you enable NVMe tiering, but you can choose to disable it at a per workload basis or a per VM basis. This is important because not every workload is going to actually perform optimally with memory tiering. Things like high performance computing applications, things like in-memory databases, they're not going to really want even their cold pages to be moved to slower NVMe tier. It'll impact the performance. One very obvious use case for memory tiering is VDI desktops. Large, kind of low intensity workloads can really take advantage of memory tiering, and you'll be able to have more virtual machines consolidated on a single host. We've been doing a lot of work with vGPU profiles in recent years. With the proliferation of AI/ML workloads, there's a huge increase in the number of customers that are running these sort of workloads that leverage GPU hardware. And in partnership with NVIDIA, with the vGPU technology, we've added more advanced features to vSphere and VCF. What we're going to talk about here is just better visibility over what GPU capacity you're currently using. You now have an easy to glance at a cluster level, the vGPU profiles in use in your environment. You can see the consumed instances of those vGPU profiles, any remaining capacity, the total capacity, so the administrator can see at a glance their total GPU usage. It allows for easier forecasting and even identifying maybe some users that are using too much resources than they realistically need to. We've also made vMotion for vGPU-enabled VMs much better. Starting with the fast suspend resume. Fast suspend resume, like I mentioned, comes into play when you're doing live patch. There were some performance problems with fast suspend resume and vGPU profiles in previous releases. It could take up to 40+ seconds for the fast suspend resume to complete for the vGPU-enabled VMs. We've taken that down to under 2 seconds in most workloads, and it will depend on the size of the GPU profile. We've also improved the vMotion speed and stun time for vGPU-enabled VMs. Again, we've seen performance improvements going from 22 seconds all the way down to under 5 seconds. We've even seen cases where we had extremely large GPU profiles in the 600 gigabyte range that would time out with vMotion. The stun time just exceeded the capabilities of vMotion. And those workloads are now able to vMotion, again, in approximately a 20-second stun time, which sounds like a long time, but in vGPU world, that's extremely fast. And we're getting faster with every performance release. We've also improved DRS's intelligence when it comes to GPU placement of virtual machines. If we take this example on the slide, where we've got 3 ESXi hosts, GPU VMs, 4 GPUs per host, this might look like optimal placement. We put 1 GPU VM across our 3 hosts. Now, the problem with that placement is it doesn't account for the potential for larger size GPU-enabled VMs to enter the cluster. So we have this green VM, it wants to use 4 GPUs. We have those GPUs, but they're split across multiple hosts. So DRS will actually learn a bit better about the usage and make better placement decisions for these VMs. And it would actually make a placement decision more like this, so that it frees up an ESX host for the future potential GPU-enabled VM. But we can take it another step further as well in VCF 9 by creating GPU reservations. So this works similar to CPU and memory reservations, but they're for the GPU resource. And these are defined initially in the supervisor namespaces. This will allow that the GPU will be available for that potential VM, and it can get placed and power on. And the last little bit just in this vSphere compute section is just a little note on hardware version 22. We typically release a new hardware version with vSphere releases, and vSphere 9 is no different. We're up to hardware version 22. It includes some of the usual things like increased CPU maximums up to 960 CPUs, the latest CPUs from Intel and AMD, the latest guest operating system support. It introduces support for our initial availability of what we call confidential computing using new AMD and Intel technologies, and it revises some of the TPM specs just to keep up to date with the industry. We have some new guest customization APIs to allow you to do guest customization while a VM is live. Previously, that required the VM to be powered off. And in the virtual NVMe space, we had support for read-only NVMe devices using write protection. So I'm going to hand it over to Pete now, who's going to take us through what's new in the vSAN space.
All right. Thank you very much, Phelan. Let me go ahead and share my screen, and we're going to spend about the next 10 minutes or so taking a brief look at what's new in vSAN for VCF 9. There's a lot of really compelling new capabilities, new enhancements within vSAN for VCF 9, and we're just going to look at some of the highlights of that. Now, one of the most compelling elements that we've introduced is the introduction of global deduplication for vSAN. And this is specifically vSAN ESA, as we already had deduplication for the original storage architecture, or vSAN OSA. But global deduplication in vSAN ESA is much more powerful, much more space efficient. Let's look at a few of those capabilities and distinctions that really make it special. First off is that the new global deduplication capabilities in vSAN for VCF 9 are extremely effective. We do this through a number of new techniques that aren't a part of the deduplication capabilities within the original storage architecture. First is that we have a global or a cluster-wide deduplication domain. That means that all of the data that lives within a vSAN cluster is eligible for a deduplication. So that increases the probability that you're going to be able to find like data and hence be able to store the data in a much more efficient way. We wanted to make sure in the design of this that we weren't going to interfere with the performance capabilities of vSAN and the demands that those VMs that you have require. So this deduplication capability runs asynchronously, meaning that it's going to run in the background and it's going to throttle up or throttle down based off of the conditions of the cluster. Now, this adaptive throttling means that as a user, you don't need to make any adjustments or tuning capabilities based off of the conditions of the cluster. It's going to take care of it for you. And what this results is that you can gain the benefit of that lower cost of storage, being able to store more data in your cluster without any additional administrative burden. Now, we're fully supporting many of the other features that are typical in a VCF environment, things like data compression, snapshots and clones, erasure coding, and so forth. One thing I do want to note, however, is that we are initially offering this capability in a limited availability standpoint. It's going to be released as a part of the first patch within VCF 9.0 or patch 0.1. And this limited availability simply means that if you're interested in this capability, you'll be contacting your Broadcom representative and they can walk you through the steps for that. Look for a wider general availability of it at a later time. Now, when we think about this notion of cluster-wide deduplication, this offers a significant benefit that you can't get from traditional deduplication techniques in a 3-tier storage architecture using storage arrays. In those conditions, the deduplication domain is limited to the storage array itself. So at any point in which you add additional storage arrays, you're essentially splitting your deduplication domain in half or quarters or thirds or whatever the case may be. Within vSAN ESA global deduplication, anytime you add additional hosts to the vSAN cluster, that's going to increase the size of the deduplication domain. So as the cluster increases, your efficiency increases, and that cost of storage effectively goes down. Now, we've made another nice new improvement for vSAN storage clusters. Storage clusters are a way of providing centralized shared storage for your vSphere clusters. This new capability is called network traffic separation. And what this does is it gives you the ability to tag a VM kernel port that is tagged for backend vSAN traffic that is responsible for making sure that the data is resilient and rebalancing the data and repairing the data when needed, and separate that from the front end vSAN traffic that is being sent to and from the vSphere hosts that are mounting the data store of the vSAN storage cluster. This is going to offer improved performance and improved flexibility as well as far as a data center design. So you can have a vSAN storage cluster that lives within a single rack and keep all of that vSAN traffic within the top of rack switches for that single rack, while the other vSAN traffic that is servicing those VMs will traverse across your spine to the respective vSphere hosts. So a really nice new feature here in vSAN for VCF9. We've made some nice new improvements within vSAN file services as well. We've effectively doubled the number of supported shares per cluster when vSAN file services is enabled. It was previously 250 shares per cluster in vSAN 8 Update 3 and VCF 5.2, but now it is up to 500 shares per cluster. And this is really important for many of our customers who are running cloud native applications that need persistent volumes and have a lot of those cloud native applications. And this should really go a long way in being able to meet some of the requirements from many of our customers. Now, another new and extremely compelling aspect of vSAN for VCF9 is the introduction of vSAN to vSAN replication. Now, this comes as a part of the VMware Live Recovery add-on. It's essentially a licensing SKU that is tied on that extends the capability of a feature that we introduced in the last version of vSAN, known as vSAN data protection. So what this allows you to do is that it allows you to automatically protect your VMs, not only locally using the highly sophisticated, highly efficient vSAN ESA snapshots, but protect those VMs remotely as well. Now, this is all built in to the UI and exposed using vCenter Server as well as the VMware Live Recovery add-on. But this simply extends that capability so that you can protect this data when you want and where you want. And again, all using sort of that notion of set it and forget it, retention periods, frequencies, and so forth that meet the requirements of your organization. It does fully support an aggregated vSAN HCI arrangement, so standard vSAN HCI clusters, as well as a disaggregated arrangement using vSAN storage clusters. We've made some really nice new improvements as it relates to stretched clusters, and we'll just walk through this really quickly. The first one is the ability to support vSphere clusters that are stretched across 2 sites when mounting a data store served by a vSAN storage cluster that is stretched across 2 sites. In the past, one of the challenges is that the vSphere cluster had no notion of these geographic sites or fault domains. Well, we've introduced logic there that allows the vSphere cluster to sort of understand that notion and not only fail over correctly when there is an issue with one site, but also provide an optimal data path and the appropriate data path while things are in a non-failure state. That is going to improve the efficiency essentially of the data traversing the network. Next up is we've introduced a brand new site-wide maintenance mode feature for vSAN stretch clusters. And this capability is going to make entering a vSAN stretch cluster into maintenance mode much, much easier. In the past, you had to walk through several steps and make sure everything was working correctly in order to achieve that. Now it's all a simple button within the UI, and it runs through all of the pre-checks and the entire workflow to enter that host or that site into maintenance mode. So you can perform your maintenance activities, switch upgrades or host upgrades, whatever the case may be. And related to that feature and that capability is a sort of a safety mechanism in the event that you were to have some sustained double failure during the time in which you have that site in a maintenance mode status. And what this is going to allow you to do is to initiate a manual site takeover, which will allow you to reinstantiate the data that was living on the one site that was under maintenance mode so that you can get all of your VMs back up and running in an automated and an easy way. In the past, you would have to reach out to our global support team in order to make that occur. So this should go a long way in making that process easier. So with that, I will hand off to Dimitri, I believe.
Yes, thank you very much. Here we go. You should see my screen. So now let's talk about networking. The networking in VCF 9.0 has also a bunch of enhancements, but since this session or this section is only 10 minutes, I decided to actually highlight one specific enhancement, virtual private clouds, VPC, because that's a big thing in clouds, public clouds, private clouds, and especially vCenter VPC. And you'll see in the middle, I have a large demo, and that should give you a good understanding of what it is. Now, to give you a complete picture, I'll have also at the end the full list of enhancements, but very, very few words of what they are, because again, it's only a 10 minutes session. So virtual private clouds, what is it? It's the same as what you have in public clouds. It's a network bubble cloud tenants can create for their applications, and they can create one or many networks within their bubble and then plug applications in them. So they can also control the communication between those networks, allow or block traffic within their bubble. Now, all that can be configured through a UI, click, 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 or through an orchestration such as vCenter Power CLI, VCF automation, or any other orchestration tool you like, such as, for instance, like, say, Terraform. And so at the end, you have a bunch of network bubbles, VPC, for each of your applications, divisions. And by default, VPC can't communicate with each other for security and isolation reasons, but of course, communication can be allowed if you want to. So now, how does it work? So let's say you have a VPC with a couple of subnets, web and app, and since we're talking about VCF, I mean, obviously those VPCs are inside hypervisors ESX, and those ESX are connected to a couple of networks, vMotion, vSAN, management, which is not represented here, and one I'll call vNetworking, which is your NSX TEP overlay network. And so within a VPC, you have automatically a VPC gateway, which is a distributed router, so inside each ESX. That's it for visual simplicity. I'm showing here only that VPC gateway in ESX1. And so when a VM needs to reach its default gateway, it always does it locally. And then if it needs to talk to another VM, which is physically in another ESX, that traffic is encapsulated through our NSX tab tunnel. So the physical fabric doesn't need to know anything about those VPC networks. And so you could represent that VPC this way because it's completely decoupled from the physical fabric. Okay, so now I have a demo to explain that in a much better way, because that's the best way to understand things. It's to see it in action. Here is my freshly deployed VCF workload domain and its vCenter. Let's use vCenter now to deploy two new finance and marketing two-tier applications with dedicated isolated networks for each. The vCenter admin already deployed the compute and storage of that application with the finance and marketing web tier and DB tier VMs. And now the vCenter needs to create the network for those two-tier applications. But this time the vCenter admin won't open tickets to ask the network team to create the new VLAN, default gateway, DHCP servers for each finance and marketing application. The vCenter admin will create those directly from vCenter on his own. So for that, he goes to vCenter networking and virtual private clouds. And you can see that at the VCF workload domain deployment, the network connectivity has been completed. And it has been completed with an external IP block 31.31.00/16. So any new VPC public network will come from that block. By the way, that IP block was provided at the deployment of the VCF workload domain by the company network administrator, who obviously owns all IP addressing in the company. So let's go back to VPC and create that VPC finance. I'm calling it VPC finance, and let's provide a private IP CIDR 10.151.0.0/16. The company network admin is not involved in the VPC private addressing, since those private IPs are limited inside the VPC. They'll never be used or be seen by the physical data center and the outside world. So that's it. The vCenter admin creates a VPC, a virtual network bubble, for his new application finance. Now he can create the two subnets, public and private, needed for that application finance. So let's create the first subnet, FinWeb, and let's make it public because I want the external world to be able to reach it. And let's make it small since I have only one IP, so 16 is more than enough. And let's use DHCP for my VMs. And now let's create the second subnet, FinDB, and let's make it private because I do not want the external world to reach it. Only the web tier can be reachable by the outside world. Now let's plug my finance VMs to those VPC subnets. There are two ways to do that. Directly from VPC, and that's what I'm doing for my web tier VM, or editing the VM and you can see here for my DB tier VM, I have the VPC networks in their own tab to help the vCenter admin to select the right network. Let's power on now the VMs. And waiting for the application to boot up, let's look at another cool thing available in vCenter VPC. Here you have a nice graphic, a nice representation of the VPC networks with the different subnets and the VMs attached to them. And directly from here, you can also see the VM IP address. So here is my web tier IP address, and I can access the new finance application that the vCenter admin fully deployed compute, storage, and network from vCenter UI. And here we go. The external users have access to the web tier, and the web tier has access to the DB tier. And you can see the external users do not have access to the DB tier. Now, if you want to provide external users access to the DB tier, then the vCenter admin on his own can create a one-to-one NAT, also called external IP, for that DB VM on a private network. Here we go. So now external people have access to the private DB VM through its external IP public, and that access can be via ping, or that access can be via any other protocol such as SSH. Okay, so the vCenter admin fully deployed the finance application, compute, storage, and network, and he needs to do now the new marketing application. So the vCenter admin could follow the exact same steps with 50, 60, click, click, click. But this time he doesn't want to do it via UI. He wants to do it in a faster way through automation. And for that, he will use PowerShell, a PowerShell script that will do all of that. So here is the script. And let me launch it. In a couple of seconds, the whole marketing application is deployed, compute, storage, and network, by the vCenter admin through a single click or a single script. From the UI, the vCenter admin can now look at the new VPC marketing topology, or can look at all the VPC topologies. And from there, he can find a specific VM IP, such as the marketing web frontend VM. And so now, with this information, external users can access the marketing app. Here we go. And now, if people want to access the DB tier app, which is in a private subnet, that's through its external IP, which can be easily found also in the vCenter VPC topology. Here we go, 31.31.03, and I can access it now. This wraps up the demo of vCenter VPC with full deployment of applications by the vCenter admin. Okay, so I'm already running late in my 10 minutes. So yes, VPC, the goal of VCF is to enable public cloud experience for your private cloud, and definitely VPC is a core building block for this. And it relies behind on NSX, but as you've seen, you don't even need to go on NSX, UI, API, whatever, to consume it. You can do it from vCenter or some other components, VCF components as well, such as VCFA, VCFOps, VMware Kubernetes services, and HCX. Okay, there are much more in NSX or VCF networking in 9.0, but I'm already running super late. So here's the list, and happy to go in those in details for any of those points in on another venue. Thank you very much.
Thanks, Dimitri. Let me switch the display. Okay, so I'll cover HCX. If you're not familiar with VCF Operations HCX, it's a migration and mobility tool that's been built from ground up and has two core components, networking and migration types. And this really helps with, excuse me, migration of workloads from within vCenter environment, so maybe an older version of vCenter to new VCF 9.0, or even between KVM or Hyper-V into vSphere or VCF environment. We can also do migration between different hardware vendors in terms of CPUs. So if you have AMD and want to move to Intel or vice versa, HCX can do that, help you with all that. So now we're going to focus on what's new in 9.0. So as Dimitri mentioned, virtual private cloud, VPCs are new in 9.0. And if you like to utilize that, you can use HCX to migrate your current workload from maybe vCenter and running workload on VLAN directly into the VPC subnets. You can also do network extension. So that will allow you to have a non-disruptive workload migration. So you do not have to change your IP, you don't have to change your MAC addresses, and you might lose a ping or two, but that's small disruption. So you'll be able to do a vMotion into VPCs, and you can do this at large scale. Can do up to 1,000 virtual machines is the scale number in VCF 9.0. So here I have some animation, but these scenarios are some of the supported scenarios. They're not all of the supported scenarios. Otherwise, the script or the PowerPoint will become really busy. So I picked and choose some of these scenarios. Similarly, we can also do migration into supervisor cluster. And so the networking of supervisor cluster is done via VPC. So you have VPC subnets available there, and you can use HCX to do the migration to the supervisor cluster also. The important thing to note here is that only the bulk migration type is available in VCF 9.0, which means that bulk is a type of migration that force reboots the virtual machine. So there will be some downtime as we will do the force reboot of the virtual machine. But it also, bulk migration adds other cool capabilities, like if you were to do upgrade of VM tools or the hardware versions of the virtual machine, want to run some PostScript, have opportunity to do all that with that migration type. Another quick point to note is no L2 extension or network extension feature available with this use case. And again, I have some quick animations there. Next is the federated environment support. So if you have multiple sites and you're using NSX federation, you have your global manager, local manager. Now you can see those segments within HCX and can migrate into those segments, because you can do the VLAN to VLAN, but to local NSX, and also to the global is supported. And one quick point I will mention here is that the global segment is supported, but we do not do network extension here because the federation itself has NSX stretch that's going on in the global segment. So we do not on purpose do HCX L2 extension. We prioritizes the network that's provided by NSX. Non-disrupted workload migration to NSX VLAN. If you have a customer you're using NSX VLAN, you can also do a migration from or to NSX VLAN. That is also supported in HCX 9.0. So these were the 4 new destination network that were supported. So I wanted to highlight that. The other, so we're going to switch gears for the couple 2 slides, and we'll talk about the migration planning. So customer after customer, we have seen that when customer put time into the planning phase of the migration, we see the success rate just shoots up. We see a lot of success with that. So keeping that in mind, we're very excited to introduce the migration planning itself inbuilt in VCF operations for network. and it gives you a step-by-step guide to build the plan around your virtual machines that you'd like to migrate, and starts with workload discovery, or application discovery rather. So it checks, like, how many virtual machine builds up an application, what are the dependencies of this application in terms of networking or other resources, common services it might be connected to. So it provides you a really nice virtual display of it, and also creates a plan around it. And you can, and it's automated. It's a step-by-step process. You can go through it with VCF operations for networks, and with a click of a button, once you're done with this plan, we can execute from the same screen, and the execution happens via HCX. So all the whole migration plans automatically moves into HCX as a wave, and you can execute, and it get executed from there. So everything, like what virtual machines will get migrated, what network will be used, what storage will be used on the destination side, all that get planned and migrated with the HCX. So it's a seamless experience, two solutions working very closely together, and you don't even see that happens in the back end. So with that, I have a quick demo. So I'm going to switch to my present video, and we'll do a quick demo. Different VCF component is effortless and without the need of re-authentication each time. Next, let's go over a demo. In this demo environment, I have already pre-created HCX network extension. So I stretch my VLAN network into my VPC subnet, and we'll start with the migration process. I'll click on the migrate and create a new mobility group. Here we'll give mobility group a name and select our virtual machine. So for this demonstration purpose, I'm only going to select one, so it'll be faster. And we'll spend most of the time on this screen. So this is where we will be adding information regarding my destination site. We'll start with the compute. We'll select our cluster, and then next is the storage. On the destination side, which storage the virtual machine will land into, and the migration profile. So earlier we talked a little bit about different type of migration type within HCX. Here's the list of those migration type, and depending on the use case, you can pick and choose which direction you want to go. For example, HCX vMotion, the first one, provides the regular vMotion that is available from vCenter. So you can do the same from here. And then bulk migration is the migration type that could be, migrate a lot of virtual machine up to 1,000 virtual machines, but this requires a reboot of the virtual machine. So a lot of external features, like I would like to update my virtual machine hardware, I would like to update my VM tools during the migration process. I have some custom script I would like to run in the operating system of the VM as I'm, during the migration process. I can do all that through the bulk migration. And replication assisted vMotion is really the best of both vMotion and bulk. So you can do a lot of virtual machine at a time, but it's end of the day, it's a virtual vMotion capability, so no downtime, and keep your IP addresses, MAC addresses, and all that good stuff with this particular one. HCX assisted vMotion is HCX orchestrated, so you can do a lot of virtual machine at the same time, and of course do the scheduling of those migration with HCX assisted vMotion. And cold migration is similar to the vMotion, but it's for the virtual machines that's been turned off. So for this demo, we'll pick RAV, or replication assisted vMotion. And next is the optional folder. If I like some folder on the destination side, this is vCenter folder, the virtual machine to go there, I can pick that. Same with the source formatting. I can, if I have thin provision and want to change to thick, vice versa, I can do that. If I want to keep the same, that's what we'll do in our demo. We can select that information. Next is the scheduling. So this is very powerful. You can, if you have a certain maintenance window, maybe Saturday, 11 p.m., we would like to schedule it for that time. We can do schedule those kind of windows. There are two types. One is a transfer. So especially for the replication assisted vMotion, you can do the transfer time that, okay, transfer might start right away, but the cut or switchover will happen on Saturday evening. So in this demonstration, we will just do it right away. So we'll cancel for now, but those kind of options are available to you. There are a lot of other extended options available that customer can use, like as I mentioned previously, upgrade virtual machine hardware, upgrade virtual machine tools, replicate the security tags. These are NSX security tags, and all the other options that are available, you can see. Next, we will click on the virtual machine itself and look into the network. Because I already extended the network, it knows which network the virtual machine will land into, which is a VPC subnet. So it's smart enough to understand that. But if I had to pick a different one, I can click on that NSXT VPC subnet. It's really nicely organized for VPCs, and I can click on the subnet that I'd like to pick it and execute the migration itself. So first we'll go ahead and validate it. Okay, validate went through, and next we will go ahead and start the migration. Now I'll pause here, and I know we're running a little over. I'll switch it to Kyle. But basically, in the demo, we were able to easily migrate the virtual machine within the VPC subnet, and this virtual machine lived in the VLAN network, and there was no disruption. It's a recorded demo, so I know it works. Kyle, back to you.
All right, thank you, Puneet. And again, we realize we're going through this at a rapid pace, and we apologize, but there's just a lot of information to share in a very short time to share it in. So hopefully you're getting at least a good sense of VCF 9 and all the new features and capabilities across the full gamut as far as vSphere, compute with vSAN, networking, HCX. And as I mentioned earlier, we're going to wrap up here with a quick visit of VCF operations and a new capability built into VCF operations called fleet management. So under fleet management, there's been a few questions in the Q&A touching on this, but the vRealize Suite Lifecycle Manager, or the ARIA Suite Lifecycle Manager, something we used to call the VRS LCM or the ARIA LCM, that appliance, the UI for that has now been moved into operations, and it's now accessed through this feature called fleet management. Along with the ARIA lifecycle management capability, we're also moving a lot of the traditional functionality that's available in the SDDC manager into VCF operations, and that's where this notion of fleet management comes in. So in the few minutes I have left, I am going to just go ahead and jump over and do a quick little demo just to kind of show you what this looks like. So here I am, I'm logged on to VCF operations 9.0. Here you'll see I got the fleet management section that I've been talking about. In this section, of course, we have identity and access. That is essentially a new SSO, single sign-on with a single identity broker that works across the stack. So we'll look into that a little bit more detail. We have centralized certificate management, password management that comes from the SDDC manager. We have a feature called configuration drift, as well as lifecycle, and this is where the ARIA Suite lifecycle functionality goes. And so I'll just go through these really quickly. Under identity and access management, so now we do have a single source for identity management, a single source for authentication across the VCF stack. So I go in here to VCF ops and I set up the identity source, and you'll see here I have a support for popular protocols as well as directories. So we can do SAML, we can do OIDC, we can do Active Directory, LDAP. But once this is set up, I can then go in and I can register my different components. So here you'll see I have vCenters and NSX managers registered with the identity broker. And I can go in, for example, and if I want to add VCF automation, I can simply go in and I want to say, hey, I want to use the same authentication method for automation that I use for vCenter that I use for ops. So I go in, I set up my identity broker, and then I come here and I just go in and I add automation as a client to this, and it will set it up. So you can see here, we do have the new centralized VCF SSO, not to be confused with vCenter SSO. And again, this is a centralized identity and access management for the full VCF stack. Along with that, we have password management. So we have centralized password management. This is functionality brought over from the SDDC manager. And you'll see here, I just have the ability to go in and have centralized management of all those root and admin accounts. I can update the passwords, where I can go in and basically say I want a new password, or I can remediate the passwords, where if a password gets changed outside of the SDDC manager, I can just go ahead and update the repository to match that new password. We also have centralized certificate management. Again, another feature brought over from the SDDC manager. And here you'll notice we have all the certificates for both the SDDC manager and NSX manager. We also now have the ability to manage ESXi host certificates. And in addition, we can go in and we configure our own local certificate authority. So here we can choose between a Microsoft or OpenSSL. If I go ahead and just set up a quick Microsoft certificate authority, and then I can then use that certificate authority to basically sign certificates. So here I'll take my first ESXi host. I'll come in here, generate a certificate sign-in request. And then when that's done, I can go in here and I can just basically replace that certificate. You see, it's all very easily done, all centrally managed, and I have an updated certificate here for my ESX host, and I can basically set up and have this be automated as well, so that as certificates come up on their expiration, they'll automatically be renewed. So again, a lot here. We talked about the identity and access management, the certificate management, password management. Those are the big ones. And if we go into lifecycle, again, this is where you'll see a lot of the functionality that was available in the ARIA Suite Lifecycle Manager in terms of being able to deploy instances of operations, automation, and logs, being able to expand those. We can set up depots and we can do the same thing for the VCF. The VCF SDDC Manager lifecycle functionality has also been moved in here as well. And so with that, just a real quick introduction to fleet management and VCF Operations 9.0. We've gone through a lot. Hopefully you got most of your questions answered, and I'll hand it back off to Anders to wrap us up.
I'll just say a quick thank you to everybody for attending today, and we'll call it a day. The recording will be available later this afternoon. You'll receive an email. Again, thanks for your attention, and I'll let you all go. Thank you. Bye-bye.
Thank you.